Good morning, everyone. Happy Sunday. I hope everyone's doing well. Let's give it about 3 minutes to 5 minutes. I usually like to start on the 9:05 type of mark. Let's give 5 minutes for everyone to also join. I know we're expecting two more people to join, so wait then, okay? Until 9:05, please. Hey, hello guys. I think you guys can hear me. I hope everyone's doing well. Thank you all for joining me on a Sunday morning for the CCNA class for beginners. All right, guys. So how I like to start these classes are, this is our first introduction class. We're going to be learning a lot about, so we're going to be covering through a lot of materials here today. And this is for anyone with no experience in CCNA as well. We're going to be starting with the very basics fundamentals of network, understanding the TCL and IP networking layers. We're going to be going through as well as ISO layering as well. And we're going to be talking about a lot of concepts inside networking as well. But at the end of the class, I'm going to be giving you guys access to some videos on LMS. It's going to be uploaded by today as well. It's going to show you guys how to install Packet Tracer. And I'm going to give you a small class activity for you guys, a homework for you guys to do and bring back next week, okay? Handed by next week. And usually how I like to run these classes is the class will start at 9 o'clock, but I give everyone 5 minutes to, assemble and get ready inside the class. And it will be very beneficial if you guys can join from your computer. But if not, obviously the class is recorded and you get access to the recording as well. But usually it'll take me 24 hours to at least get the recording up and give you guys access. But once I have the recording access, I will let you guys know by email stating that this that this class video has been updated to LMS and you guys can go ahead and access. Okay. Just to go over the LMS, you guys should have all got your LMS login credentials as well as password to log in. So go ahead and log in. I would suggest tomorrow. Once you start logging tomorrow, you will be seeing a couple of videos, pre-recorded videos that I just want you guys to cover. There's some things that are nice to know, and those are the things that I would like to cover in the pre-recorded videos. And anything that you need to know, we'll be doing that in class activity. Okay. And you will have assignments during this class, just so you are staying in top of the learning curve. And as well, there'll be other resources, videos from other networking personnel that I think that'll be very beneficial will be added there to support you guys in passing the CCNA exam itself, okay? And I know I also added in a couple of exam preparation documents there as well, and exam topics as well. So you guys can go into LMS and go to the scroll down all the way to the exam prep week, and you guys should be able to see it. Now, just before we get started, I do want to log into the LMS and just let you guys know there are some holiday alerts or some work schedules that I just want you guys to be aware of. If you guys do log into your LMS, which is like here. Which I'll just share my screen for this one. So when you log into your LMS, you should be able to see CCNA and IT Helpless Training. Go into your CCNA, you're part of CCNA batch. So you should see the bottom, you should see a couple of resources here. Click on them, you'll be able to see some videos, nice CCNA type of videos, and as well as CCNA question dumps, which will be very beneficial for you guys to go through towards a little bit towards the end. But I'm gonna in week one, by tomorrow morning, you guys will have another couple of videos here as well for week one for you guys to cover. This will give you guys access to some of the one is class recording. The other is some of the resources I want you guys to cover before we come into the class, okay? And same thing happened with week two as well. There's some things that will open up, so you guys will watch that right after we're done our live class and come prepared for like week three, right? Because this is 8 weeks, we don't have too much, time to, spend time on the like to know or things that are good to know, right? So we'll focus on the things that is more exam preparations or CCNA related real stuff. You will be required to install Packet Tracer, and I will give you guys a video on how to exactly go ahead and download it and get it done, and explain what does Packet Tracer does, okay, to you guys. But usually the class will start at 9:05 for everyone to come up and get ready. The class is recorded. There is some pre-recorded content that I like you guys to cover as well. Okay, there will be small quizzes to test your knowledge, and there will be lots of assignments for you guys to grow your knowledge. Okay. Any questions before we get started, guys? Go ahead.
Yeah, good morning, sir.
Mm. Good morning. Good morning.
Yeah, regarding the LMS and talking about the preparatory, I mean the exam dumps. Will it be recent one towards our exam, or the
Yes.
ones that are there? Are they just the previous ones so that we can just get prepared with it, or towards our exam, the one as in the main, as in something we need to prepare with? Because I don't know. From research, I think I was being told the DOMs are being updated regularly.
Yes. Yes. So usually the LMS, I'll keep it very updated. So I suggest the exam preparation, keep it towards the end, which will give you much more updated thing. But I suggest you go through them if you have time, go through there's some extra videos that I added in there too. There's some things, go through them as well. They're very beneficial, but I'll keep on updating them if the content ever changes or there's some added on to the exam itself. CCNA, I believe it's 200301. Yes, 200301. So if there's any content updates, I will make sure to give you guys some sort of update in the LMS as well, which you guys will have access to. Okay. All right. Let's just before we get started, let's quickly introduce ourselves. Obviously, you guys know my name is Athavan Mahendra Kumar. I'm the founder of CTech Training, and I'm the instructor for this course as well. Yeah, if you guys want to, please go ahead and tell us a little bit about yourself and what is your journey towards here. Let's quickly start this. Okay. All right. Let's start with Abby Lek. I'm so sorry if I'm pronouncing it incorrectly.
You mean me?
Yes, yes. Sorry. How do you pronounce your name? I'm so sorry.
Okay, you will go with this with the first name, which is Gabriel.
Hmm.
I think that should be more
Gabriel. Okay.
convenient for you.
Yes, yes. Thank you, Gabriel. Sorry.
Yeah, my name is Gabriel, and I'm from Nigeria.
Okay, very
A
nice.
PSW. Let me just a PSW.
Okay, very good. And
You know.
what is the exposure level in IT now?
Okay. Um, at the moment, I'm running, or let me just say, I'm almost rounding up my cybersecurity analyst
Very
course.
good. Mhm.
I've taken CCNA there, but I just want to broaden my scope in the sense that
Yep.
I just look towards probably maybe a time or in order to like teach people. And what I need to teach people is something I need to know. So that's why I'm taking this CCNA. And I have knowledge on Python and
Very nice.
some other, I think Python and C Sharp. That's all.
Very good. Very good.
Thank you.
Thank you. Thank you, Gabriel. Thank you. All right. I have the next on my screen is Gagandeep.
Hey guys, my name is Gary. I'm Canada. Um, I own a security and networking company in Canada, and I'm from different fields before, and I'm self-taught till now. So I thought it was a good idea to go to CCNA because I need a lot of IP and stuff that when I work to get done in my field of work. So that's why I'm here. I've worked for this field before, and I'm a civil engineer for the before, but life led me to this one. And so basically, I need the reason for me doing CCNA right now is it'll help me a lot in getting the projects get done faster and be more productive. But the freelancing, all that. So I have some knowledge. Basically, it's all self-taught from YouTube stuff. So that's why I'm here.
Very nice. Very nice. Thank you so much. Thank you. All right. I have next is Manjit. I don't know if I'm pronouncing that right incorrect.
Hi, it's correct. Hi, everyone. I hope everyone is good. And I'm learning CCNA course just to expand my knowledge regarding the networking. And I have recently done the cybersecurity course as well. There, I feel like somewhere these fields are interconnected, and I need to know more about it. Thank you.
Very nice. Very nice. Thank you. All right, Mr. Krishna.
Hi, hello everybody. Good morning. My name is Krishan, and I wanted to get into. I'm not from IT field, but I wanted to get into cybersecurity. As part of the journey, I believe networking is important, so I just want to learn more. So that's part of the journey. I want to take this course.
Thank you. Thank you. I have Janushia.
Hi, this is Janushia.
Yes, go ahead, Janushia.
I already studied about cybersecurity and then a short course of web development in my home country. So, and then also I dropped off my studies and then came here. Um, I couldn't join my online classes because of the time difference. So that I'm decided to study a small course here and then do my like other studies here too. That's why.
Very nice. Very nice. Thank you. Thank you so much. I have last but not least Imran.
Hi, good morning, everyone. Yeah, my name is Imran. I have done in the past work in the field, and then I was working in different industry. So I decided to come back, and I started with CCNA. I want to go for CCNP because in the past I have worked in IT support and in networks years and years back. So this is what I'm up to, and I'm hoping that I will go back into my field again. Yeah.
Very nice. Very nice. Thank you so much. Thank you. All right, guys. Thank you so much for all the wonderful introductions of you guys self. I really appreciate it. Let's get started in the class itself, so we can cover a lot of concept to cover. We have a lot of concept to cover. We have approximately 30 slides to cover today, so let's get started. Okay. And just please mind, if you guys do have any questions, you're more than welcome to raise your hands. Google does have an option. Google Meet does have an option to raise your hands. Or if I don't see it, you guys more than welcome to unmute yourself and ask me the questions. I'd rather you stop me and ask me the question and I clarify some of the things if you don't understand. That way, we can go press forward with these other modules, right? But if you have any questions, please don't be shy. Being shy does not give you any sort of output, okay? So just open up and ask. Everybody's here to learn, okay? So let's open-handedly start this course. Let's get started. All right. As I said, this is CCNA for beginners. We're going to be starting from very basics, and we're going to be working around. There will be a lot of there will be some pre-recorded videos as well that you guys will be watching in your LMS from tomorrow. But as well as anything that's neat to cover for the exams and for this topic will be covered through our live online classes. Okay. All right. Let's get started. So, welcome to CCNA Network Fundamentals. This is an 8 weeks beginner-friendly CCNA program. Build a strong foundation in networking. No prior experience is needed. Real world plus exam aligned teaching. Okay. So with these teaching methodology, what we do is we make sure that we give you a very structural program that is proven to make sure you pass the CCNA exam, okay? And give you guys knowledge or working knowledge in CCNA as well. It doesn't necessarily mean that you have to go for the exam, but at least you'll have very good knowledge on how CCNA product works or networking fundamentals, okay, for you to pass. Remember, CCNA is nothing more than the fundamentals of networking with Cisco programming. Okay, that's what CCNA implies. It's the fundamentals of networking, making sure you have a very good understanding of how network works and what are the things you can do to configure Cisco routers. And it is a Cisco certified network analyst certification, so it is a vendor-oriented certification. Okay, which means this is not something that you learn about Aruba. There's different types of companies that makes routers and switches, just like Aruba, HP. Samsung has their own switches. D-Link has their own switches. TP-Link has it. Cisco is one of the pioneers. So this is certified by Cisco, and you'll learn how to program using the Cisco's command lines and everything. Okay, you will have actually hands-on experience with Cisco command lines using an emulator, which is called Packet Tracer. How to install the videos will be released to you guys tomorrow in the LMS, and you guys can go there and look at it. Okay, how to install. It's very easy to install, very easy to set up. There's a step-by-step. I went through it. Okay. So today's agenda is we're going to be learning about what is a network, key network devices, OSI model. It's a 7-layer model, And TCP/IP models, that's a 4-layer model. IP and MAC address basics, basic commands, ping, trace route, and IP config, and how to use them. What are the different usage for those? And how would you actually troubleshoot with them, right? Which leads us into the real world troubleshooting scenarios or types. And you'll have a class activity, a homework that will be released to you tomorrow as well, okay? And it's about setting up your own home network in a packet tracer. You're going to get a video, a pre-recorded video of how to sign up for a packet tracer. And you're going to get also a pre-recorded video on how to set up a packet tracer with computers and everything, which I'll give you a briefing in this class as well. But you have a recorded video as well, separate recorded video, just so you can go through a packet tracer and set those up. And you'll emulate whatever's in your home in there, okay? So we can go around, play with that. All right, guys. So let's see what is a network. Let's get started. So a network is a simple device connected together to share information. Your home Wi-Fi is a network. Your work computer from a network. Every message you send or videos you watch relies on network. CCNA starts with understanding these basics. Device connects together, share data and internet and resources. For example, home Wi-Fi, office LAN, local area network, which will look at what is a local area network and what is a wide area network as well. Web browser. Used every day is WhatsApp, YouTube, and email. Okay. Now, without network, these are not possible at all at any circumstance. Just give me 1 second. Let me just move this screen. Foundations for IT role. Need for IT support and NOC, is network operation centers, cybersecurity, and cloud. Help diagnose technical issues quickly. CCNA is globally respected. Okay. Networking is the backbone of IT. Whether you're doing support, cybersecurity, cloud, or server management, they all rely on networking. CCNA is globally recognized because it teaches a core principle behind how networking really works, and it allows you to program Cisco routers and switches. Okay, that's the other portion of it, but it is globally recognized as a very recognized certification itself. It's a very respected certifications. The key networking device that you guys will have to understand is there's routers, there's switch, there's access point, firewall, and a modem. So what is the difference is router connects network and routes traffic, which just we'll go through when we go through a packet tracer. I'll show you visually how it looks like and everything. So, but when you think about router, it connects network and routes traffic. That's how router does. Okay, just so you memorize these terms. Switch connects device in a LAN, which means local area network. So switch, all it does is it enables you to connect multiple devices to one router. Okay. Access point, or AP, provides Wi-Fi. Firewall, it's a small device that secures the network itself. Modem connects to the ISP. ISP stands for Internet Service Provider. Okay. Whenever we refer to ISP, just remember it's called Internet Service Provider. These are the devices you will be working with in real life. You see routers and switches in every office. Later in the course, we'll configure actual Cisco routers and switches so you understand these devices on hands-on. But these are the roles of these devices. Okay. Router versus switches. So router, it is a layer 3 device. As I said, this is more for theory, and we'll go on practical right in this class as well. But just want to make sure you guys understand there's a core concept that we have to make sure you guys understand. Router uses IP address, connects connects different networks. Whereas switch, it is a layer 2 device. Okay, router is a layer 3, and the switch is a layer 2 device. Switches use something called MAC address. Connects device inside the same network. Okay? A router moves traffic between networks, like your home network to the internet. The switches connect the device inside the same network, like PC, printer, and white phone. This difference is extremely important for CCNA exam. Wired versus wireless. Internet, if you're connected to internet cable, which is a cable that looks like this. It's a blue cable. It looks like a phone line, almost like a phone line, but it'll have 8 different connectors, which is called an internet cable. It is a faster and a stable connection. Wi-Fi is more convenient and portable. Both are part of a modern network, but it offers a different troubleshooting step for each one of those. Okay, internet cable is always faster and more reliable than Wi-Fi, but most users connect through Wi-Fi. So as an IT profession, you need to know how to troubleshoot both. Why use this model? OSI/TCP, OSI and TCP and IP. So these are different types of models. Okay, we'll go through all of them as well. It breaks network into layers. Each layer has a specific job, helps vendor work together, makes troubleshooting easier. The OSI and TCP IP models exist so we can understand the complexity of networking one step at a time. When something breaks, we use these models to isolate the issue. So you guys might be confused, what is a model, okay? And I'll show you guys in just in a little bit. So this is how we actually separate how does networking work in the backend. There's actually 2 different types of model that we use. One is called OSI model, which is a slightly older model, and the newer model is called TCP/IP model, which is a newer model. Okay, we'll go through both of them, and you'll have a very good understanding what they are. But you'll see why these models are important is because the backbone of internet, how it was built, are based out of these models, and you need to start understanding this for you to properly have a full working knowledge in networking, right? So it's actually OSI model is a 7-layer model. We call them a 7-layer. The reason why we call them a 7-layer and what they are is first is a physical layer. Let me just give you guys more of a visual photo of it. I'm going to show you guys a visual photo here. Which you guys have probably seen here. So if you see this model over here, you're seeing that, okay, so it starts from the very, very bottom over here, okay? This is how the first, it always starts from the very bottom layer, which is a physical layer, which is a cable-to-cable connection. It could be either Ethernet cable to Ethernet cable or fiber optics cable to fiber optics, whatever it is, but it is a physical cable connection. It's called the physical layer, okay, layer 1. And the layer 2 is a data link layer, which is the internet to your network, right? So which is what it drives the traffic. Can you guys tell me from what we talked about before? Remember we talked about layer 2 devices. Can you guys tell me what we talked about in the layer 2 device? What do we mention as a layer 2 device? Sorry, did someone say
That
anything?
is switch.
Very good. Yes, yes. So switches are always layer 2 device. Okay. So it works on base of MAC address and there is no IP address. So, and we'll cover what is MAC address just slightly down the course. But yes, switches are layer 2 devices. Okay. So all they do is take traffic from one end to the other. So they just like, think of this like the transporter over here, right? This truck over here is just transponding the information to the router itself. Okay. And that is what a switch does. It just takes information, pass it down to the router itself. That's all it's doing. Okay. And then next we come into the network layer. And what works in a third network layer, guys? The layer 3.
Router.
Very good. Yes, very good. So the router is a layer 3 device which works with the IP address. Okay. Which is we'll talk about what is the IP address and how does it work, but it takes a package that your computer has sent to the switch and the switch sent to the router. It takes it to the assembly to send it out to the internet itself. Okay, and this is how it works in the backend. And then From there, your transponder layer will divide them into small packets and take them and then separates them and takes them out of your network, goes to the, if you're going to watch YouTube or you're asking Google for some information, it actually divides information into small chunks, movable chunks, takes it down to Google, reassembles them, gets the information, gets it back. So all it's doing is it's dividing into small packages for transporting, getting the information, and bringing it back. The transport layer, okay, which is the fourth layer. Now the fifth layer, 5th, 6th, and 7th, these are more what we call as a consumer layer, okay? So this is where your majority of your application stuff happens. So if you're opening up Google Chrome and watching, how you're watching me is through the 5, 6, and 7 layers, okay? These are the sessions layer, it's called. Do you guys sort of understand that? It's okay if you guys don't have a full understanding of it, because we're going to have class activity and we're going to have our working knowledge as well. But the thing is, for exam, you need to memorize this. Layer 1 is physical layer. Layer 2 is data link layer. Layer 3 is networking layer. Layer 4 is transport layer. Layer 5 is session layer. Layer 6 is presentation layer. Layer 7 is an application layer. This has to be memorized, okay, to pass the exam. Go ahead.
So in all these layers, when data will become a frame or packet or segment?
For you to view? Sorry, for you to view, or what do you mean by data becoming a frame? Yeah.
From application layer to physical layer, when we will say it's a complete frame or it's a data when we are troubleshooting.
Yeah, so when you're troubleshooting, when it becomes a frame is usually at the application layer, is when the application can, transpond it and display it out like something you can see, right? So it's usually the application layer or presentation layer. It's one of these. It depends on the application and the form you're using it under. But the OSI model, with the OSI model, there's not much troubleshooting now you can do. It's because most of it has been moved over to the TCP/IP model, which we'll see it's much more easier to memorize. Okay. Okay, perfect. Sorry, let's just try to find this slide. Okay. So as we talked about physical, data, network, transport, session, presentation, and application, right? Now, we're going to be going in between each one of these layers as well, okay? So the first layer you're seeing here is okay. So the first, okay. So the first layer you guys seeing here is a physical layer, which has the cable, connectors, signals, okay? It's more a physical connection itself. Things are like Ethernet cable, fiber cable. Wi-Fi is also considered a physical connection itself. Physical problem equals no connectivity, okay? This layer includes cable, connectors, and physical signals. The most issues you'll have is loose cables, wrong port, broken connectors. These are all layer 1 issues, okay? These are all considered as layer 1 issue, which is loose cable, wrong ports, broken connectors. When we go on to layer 2, you have MAC address, switches operate here, data unit frames, local network communication. Layer 2 handles MAC address, and I said we'll look at MAC address just slightly down these slides. Layer 2 handles MAC address. If a device cannot communicate inside the local network, it's usually a layer 2 issue. So remember again, if a device cannot communicate inside a local network, it's usually a layer 2 issue. Okay. This is layer 3 networking. So this is works on IP address. Router operates here. It's layer 3. Data units is packets. Connects networks together. This is the layer for routing. Every time data travels across the network or the internet, it routes at layer 3. The next is a transpond layer, which uses, there's two different methods of transponding. There's one segment called TCP, and there's a segment called UDP. And we'll go a little bit deeper into it next class, when we actually go into our more into IP addressing and how it works. TCP, think of it this way, it's more reliable. It has checks, but it is slightly slower. UDP is fast. There's no checks. It doesn't check to see if all the things that came through, but it's fast. And usually you can think of this way. Whenever you're watching anything live, it is a UDP protocol. Whenever you're doing downloading or you're watching recorded videos, it works on a TCP basis. And we'll go deeper into it and dive deeper into it. It's how your network takes it and segments it. Remember, I told you it divides into small chunks, sends it out. Same thing happens, it has to reassemble, right? So the reassembling methodology it works in, we'll look at in the next class. It's just, you can use one that is more for faster communication, like your phone line. You don't want it to be delayed, right? You don't want there to be a delay on the network itself. You want the information to come through. Even if you're missing a little bit, it's okay, but you'll still make it through and you want to have a live conversation, right? Whereas the other one is more of a recorded or a downloading instance, okay? And you want to make sure that you have downloaded the right file, or you go down, make sure that whatever you have taken up or whatever you have taken inside, it is at a full package, okay? We'll go through the more of the inside workings of it just in the next class itself. TCP ensures reliability, like packet tracking. UDP trades reliability for speed, like video calls or gaming. Both are important, but it just depends on the scenario of what you use it after, right? So there's all these scenarios. We'll go through all these scenarios in next class, and you'll be very comfortable with TCP. Okay. Supported apps like HTTPS, DNS, VoIP. We'll go through all these. VoIP is just voice over IP. Okay, it's what a lot of modern offices are using as well, but it's voice over IP. And HTTPS is whatever you use for your websites. So that's how your website works. Layer 5 is a session layer. Layer 5 is a session layer. Its main job is to maintain the start, maintain, and end communication between devices. Think of it like this. Zoom call. A session is created whenever you join this meeting, right? The Google meeting. Think of it like a Google meeting, right? Think of it like a session is created for you to join the meeting itself. Remember, you requested for joining in. It stays active as long as you're connected. You know how you guys are active and looking at my presentation, you can hear me talking. So you're having an active session, okay? It closes. It's either when I end the meeting for you guys or when you guys ever jump off the call, right? It closes the session. Example includes like logging into Gmail and staying logged in, a video conference call session, RDP, a remote desktop session. The session layer ensures that connectivity remains active and stable while data flows between the device. So layer 5 manages communication sessions, open, maintains, and close connections, handle login session and authentication, ensure two devices stay connected. For example, staying logged in into a website or into a video call, like what you guys are doing. Okay. Presentation layer. Layer 6 is a presentation layer, the translator of the OSI model. This layer is responsible for converting data into a format that applications can understand. It manages encryption, like HTTP, TLS, and SSL. We'll go through the encryption stuff as well, don't worry. Compression, zip filing, compressing videos, and data formats. like JPG, MP3, MP4, PDF, documents, whatever it is, the formatting. For example, when you visit a HTTPS website, which is it's a secure website, layer 6 encrypts your data before sending it and decrypts it when received, keeping your information secure. Encryption is just another word for securing something. Okay, it's just encrypting. It's just securing it. Okay, if you guys don't know what the word is. Any questions so far, guys? Okay. Layer 7 is the application layer. The layer users and interact with directly. This is where the apps you use connect to the network. It includes services and protocols like web browser, email, domain lookup, DNS, and file transfers. When you open Google Chrome, Outlook, WhatsApp, or Teams, you are interacting with the application layer. Important is, layer 7 does not mean the application itself. It means the network service used by the application. Close layer to the users. This is the closest layer to the user. Provides network service to application. Supports software like browser and emails. Common protocols are HTTP, DNS, FTP, and SMTP. Example, Chrome, Outlook, and WhatsApp. Now, I'm going to give you guys another cheat sheet with all these port numbers and everything that you guys need to memorize. There's about, I think, 40 ports, I think, that you guys need to memorize. It's very, there's a sheet on it. You just have to look through it, memorize it. It's for the exam itself, okay? For you guys to pass the exam. The next big thing what we're going to talk about is TCP and IP model. So the 7 layers is called the OSI model, okay? Right now, we're going to be looking at a TCP and IP model, which is more of a newer version of these models, okay? It's much more broken down, and it's just the 4 different layering that's all this, okay? What is a TCP model? The TCP IP model is an actual model used by the internet today. So OSI was a very previous model that they used to use. It's no longer the part of the internet model itself, okay? But it is TCP and IP. It is today's internet model today, okay? It defines how data moves from one device to another across a network. Where the OSI model is a theory, TCP and IP is a practical and used in real world. This model has 4 layers, not like the 7 layer in OSI. Okay, these are the model. The first one is application layer. The second one is transport layer. Third is the internet layer. Fourth is network access layer. So it's just now the modern one is just 4 layers. Okay, and this is how your network is actually working. OSI just complicates it because that's how internet was built. That was the theory behind internet, how it was built, right? But this is actually what as we have came down to. The TCP IP application layer is the closest to the user. Now, instead of the previous OSI 7 layer, the 4th layer is the closest to the user itself. Okay, this is where the network service communicates with the application like Chrome, Outlook, and WhatsApp. You see, there'll be a lot of similarities, but 2 or 3 layers are into one. Okay, it includes protocols such as HTTP, HTTPS for websites, DNS for domain lookup, SMTP/IMAP for email, FTP for file transfer. TCP IP merges the OSI sessions, presentation, and application layer into one layer because in the real world, these functions happens very close together. So for layer 1 application layer, it provides service for application like web, email, and DNS. User-facing protocols are HTTP, HTTPS, DNS, SMTP, FTP, and you'll know all these too. Don't worry, I'll give you a cheat sheet and we'll go over them. Combines OSI layer 5, 6, and 7. So if we go back here, so it pretty much 5, 6, and 7. So session, presentation, and application model is all into one in the TCP/IP, which is just the application layer itself. Okay? Now the layer 2, which is transport layer. The transport layer handles communication between devices. It's used two main protocols, TCP and UDP. TCP stands for Transmission Control Protocol, which is reliable, slower, guarantees delivery. Example, when you're going to a website or when you try to visit an email or bank. Okay? As I said, we'll go even in depth even more into this. But the next is UDP, which is User Datagram Protocol, which is fast, unguarantee of delivery. Example, video streaming, live gaming, phone like voice over IP, like VoIP phones, your live stream of anything or live stream of TVs too, right? They're all under UDP protocol itself. This layer also uses port number to direct traffic to the right service. For example, 443 means it's HTTPS access. Port 53 is a DNS access. Port 25 is SMTP. And you might be confused of what the ports are. What do you mean by ports, right? Ports are nothing more than like a window inside your computer, almost like a small entry or exit points into your computer or into your network itself. So what these allows to do is for applications to travel outside or into your network or into your computer without any interruptions. They're almost like a door, dedicated door for these applications itself, okay? And there's some things that are set default, and there's something that's set as by random. To be very frank, I think all your computers or any networking device can open up to 65,000 different ports. 65,500 something, I think. I forgot the exact number, but it's 65. How many ports? I'll just search it. I believe it's 65,500. 65,535. Yeah, I was almost sure. Yeah, 65,535. Okay, but those are, but at least normal your Windows service everything uses about, I think, 30,000 ports. So there's still about 30,000, or I think 10,000 ports that are openly available for anybody to use for any type of purposes. And this is when you learn cybersecurity and ethical hacking, you'll learn to open up ports without the knowledge of the user or without the knowledge of the computer to take advantage of the computer, right? And you learn how to protect them too. That's part of the cybersecurity scope. But we'll go through in depth into the ports as well, how it works, and what are the default ports, because you do have to remember that I think the top 40. It's very easy. I'll give you the sheet, you just memorize it. It's not too hard. Okay? So, layer 2 transport layer establish communication between devices, uses TCP and UDP, uses port number to identify services, ensure data reliability or speed. Layer 3 is the internet layer. This is where routing happens. The internet layer decides how data leaves your device, how it gets routed across multiple networks, how it reaches a destination. Key technology here is IP, Internet Protocol. IP stands for Internet Protocol, okay? ARP maps IP to a MAC address. We'll look at what is ARP. ARP. It's so this is how it knows what IP address belongs to what computer. So your computer will have a unique address. It's called a MAC. Well, I'll just go through just a little bit more slides, so I'll go through over it. But your computer has a specific identification number. It's created by the manufacturer, actually. It's created by whoever has created your Wi-Fi chip or your Internet card. All device that connects to online or connects to network will need to have a MAC address, which is like a physical address itself, okay, to the device. You can only borrow an IP address from your router if you have a MAC address. Now, if you see me again here, what I said is you can only borrow an IP address, okay? You'll never own an IP address. You always borrow it. So you're only borrowing the IP address because you have a MAC address. It's like assurance. And you have another thing called ICMP. So when I was going back to MAC address, and then with the MAC address, you go get an IP address, okay? So for the router to remember what IP address belongs to which MAC address, it creates something called an ARP pool or ARP table. ARP, Alpha Romeo Peter, ARP, okay? It creates a map. So without going to the router, your switch can actually pass the information down to the proper personnel if you're asking for it. ICMP used by ping and traceroute. So ICMP is another protocol as well. We use to make sure if a computer is online or offline. And I'll show you guys what I mean by that just by live demonstration. Just to give me a couple of minutes and I'll show you guys. There's some things that we'll go over in this class as well. This is a layer that makes the internet possible. Routers operate here. So even in the TCP/IP model, router operates in the layer 2. Okay. So its thing is responsible for routing, uses IP address, moves packet between devices. Key protocol is IP, ICMP, ARP. This is the layer 4 now, network access. This layer deals with actual movement of data across your physical network. It includes internet cable, Wi-Fi signal, switches, NIC cards or network interface cards. Those are part of a desktop or you can get it on a laptop as well. MAC addresses. In this layer, data is sent as a frames and then converted into bits that travel across copper, fiber, or wireless. Why TCP/IP matters is it's a real world model used on all networks. Internet is built on TCP and IP, the modern internet, okay? Requires for all modern IT roles for you to understand this. Maps directly to the Cisco exam concept as well. So the reason why we suggest that you need to memorize the OSI model and the TCP/IP model is both of them are required in the model in the exam as well. There is questions where it asks you literally to do a drag and drop to align which model, which layer it is, and they won't say layer 1, layer 2, layer 3. It'll just be network layer, network access layer, physical layer. So you just need to make sure you memorize them, so you can actually do that. And it is a very thick portion of market itself. Okay, unlike the OSI model, which is mainly for learning, the entire network actually runs on TCP and IP model. Everything you do online, Netflix, WhatsApp, YouTube, banking, follows this 4-layer model. You must understand TCP and IP to work in IT, networking, cloud, cybersecurity, or NOC role. How OSI and TCP/IP works together. So this is just a chart I have put in together for you guys, so you guys can visually see which layer gets compressed into what in the TCP and IP model versus the OSI model as well. Okay. So if you see here, the layer 5, it's in the TCP model, from OSI model, TCP is layer 5 to 7 is actually the application layer in TCP/IP model. Layer 4 is transport. Layer 3 is internet. Layer 1 and 2 is in network access. The OSI and TCP model explains similar concept using different level of detailing. OSI breaks it into 7 layers for learning. TCP/IP simplifies it into a 4 for real-world usage. Real-world example is app layer is YouTube app, which is a HTTPS request. Transpons TCP port 443. Internet IP routing to Google. Network access is Wi-Fi or internet frames. So if you think of it this way, if you just put what we're trying to do is we're trying to get to youtube.com, right? So your computer must be connected to Wi-Fi or internet cable itself, right? That is a layer 1. That's where it starts off, right? Now you're trying to search up for google.com or youtube.com, right? YouTube is it's still owned by Google itself, so you're still going through that Google and you're searching up, or the request itself is going to Google, right? The next is it uses a TCP 443, which is the HTTPS connection, to establish a session to open up the youtube.com for you, YouTube app for you, right? In your phone or your TV or your computer itself. And this is how it works exactly. And we'll see some live demonstrations throughout this course as well, just so you have a very practical understanding. IP basics. We'll go through actually IP address and subnetting is there. We have a special videos for it as well, and we'll have a class working session as well to just understand the IP addressing and subnetting. But this is one of the most important topics in CCNA. Every device on network needs an IP. You'll learn subnetting next week as well. But example is 192.168.1.10. there's actually two different sets of there's two different sets of IP addresses. One is called a public address, one is called a private address. And you need an IP address for routing. There's 4 octates, which I'll show you guys just in a little bit when I do the live demo of it. Okay, we'll go through some troubleshooting steps as well. The next is a MAC address basics. So MAC address is just nothing more than a hardware address that is physically on your computer or on the chip that is created for network access. Okay, unique to every device, used in local communication, works with ARP. Okay, and these hardware addresses are created by the manufacturer of the hardware itself. If my network chip is created by Dell, then Dell will create a unique MAC address for the device itself, and it will never be repeated. Okay, usually. MAC address are physical identifiers. When IP needs to reach a device internally, ARP finds a MAC address for you. And we'll look at what is ARP and how does it work too as well. ARP is just a bigger concept of it, but I'll explain to you how it works. Okay? Basic network commands. So these commands will help you diagnose 90% of the issues. Later in CCNA, you'll run Cisco commands on a real simulated equipment. Okay? Just to go through these commands, I'm going to share my other screen so I can open up a command prompt. I'm going to show you guys this in my computer, which I'm using as a Windows 11. And I'm going to show you guys in a CMD. There's a command prompt. You guys are more than welcome to try the same thing too, just to simulate some of these things. And all you have to do to open these up is, okay, I'm going to open my start and search for CMD, which stands for command prompt. Okay, if you're usually using Linux or Mac OS, it's called terminal. We open that, and I'm just going to share this window itself so it's clear for you guys. Okay, so this is my CMD portal itself. Okay, so the first thing that command prompt you'll always want to do is get the IP address of your computer. Okay, and I'll show you 2 different ways, and I'll show you the differences. Okay, so for Windows, it'll be IP, I as in India, P as in Papa, config, CONFIG. Okay, IP config. What this will do is this will list out all the network ports are things that allows your computer to connect to the network with. If there is a connection to the network, it gives you the IP address that it got. Okay, if there's no IP address, then you won't see an IP address here. So for example, I type in the command over here. Let's scroll down, and you can see the internet adapter. There is a manual. I mean, I think I set this up manually a long time ago, but this internet adapter is set up, but there's no internet connection there. But if we go down here, I'm connected through wireless. This is wireless LAN, Wi-Fi adapter. If you see here, there's IPv6 address. There's IPv4 address, subnet mask, and default gateway. Let's focus on these things for now. Okay, IPv4 address is an address that's been issued to me by my router itself. Okay, my router handles this, just give it to me. So these are what's called a subnet mask. And remember in the other presentation, I told you there will be 4 octates in this one over here. You see how it says 4 octates. So it's 0 to 255, right? So what is octates are, like you see what is here. You see it says 255.255.255.0. That's how actually we separate the networks. So the 255, 255, 255. So which means that there's 255 devices that can connect per octate. Okay, we'll go through it when we go through a subnetting thing, but these are each section in these 255, they're called octate. This is 1 octet. This is 2, 3, 4. There's 4 octates here. Okay, and it's just a bit separations into. We'll go over it when we go cover IP address, but just remember when we say octate, it's a dot in between how we separate them. Okay, this is my computer's IP address. This is how I said it gets divided, right? The network gets split up, and we'll go through them next class as well. But the default gateway is actually the address to my router itself, okay? What's my address to my router? And my router is at 192.168.0.1. And this is something called a private network, okay? This is inside of my router itself. This is not public. And we'll go over the difference next class as well, but I just want you to get the concept. There is two separate networks, and most of you guys, what you're using right now on a computer, it is a private network itself, okay? Okay, now there's another thing too, which if you do ipconfig again and type in all, this will pretty much give you a listing of everything that's on in the computer that can connect to the network. Could be either Bluetooth device, Wi-Fi device, or physical internet connection device as well. So if we go back here, oh sorry, go scroll down here. This is where I typed in ipconfig/all. You see here, this tells you my host name, which is my computer's name, which says, some information about my networks and everything. Let's scroll down here. You see this is an internet adapter, and you see you don't see an IP address, right? Which means there's nothing connected to it, and it's not set up yet. But if you see here the physical address, can you guys tell me what you guys think this might be?
The question again.
MAC address?
Sorry, MAC address, yeah. This one.
Okay.
MAC address, yeah. Yeah, this is your MAC address. So this is your physical address, actually. Remember, I told you that every manufacturer has their own address, right? Because I do have virtual machine installed on this computer, it does have emulated internet adapters. You'll see some with the exact same MAC address or just slightly different. So this is my Lenovo USB adapter, okay? So this is actually my docking system. Docking system has its own internet adapter, so it has to have its own MAC address. Remember that it's not just your computer what has MAC address, right? Every device that can connect to the network will need to have a MAC address, which means if you have a USB internet adapter, look in the back and you'll have a MAC address. So I'm just trying to find a USB internet adapter, which I should have tons of it laying around. I just can't find it right now. But each one of those will have a MAC address. Anything that connects to a network will have a MAC address. Your smartwatch that connects to Wi-Fi will have a MAC address. Hey, your smart mug, if you have a smart mug that connects to Wi-Fi, it will have a MAC address as well, which I have a smart mug over here. I just turned in the back. No, it's peeled off the label. But usually you can get a label. On the label, it will give you a MAC address as well, okay? Which all devices that connects to online must have. Wi-Fi must, or internet, it must have a MAC address, it's physical addressing. And that has been created by the manufacturer who makes a device or who makes the chip itself, okay? Now, if we scroll down here, you'll see these are all virtual boxes. These are all virtual keys. These are all something, we use for virtual machines, okay? So they're a bit different. You'll see here Microsoft Wi-Fi Direct. This is another Microsoft's Wi-Fi card. Let's see if we go scroll down here. This is my actual Wi-Fi card. That's my physical one I'm using in my laptop right now, which is what's connected to my office network here at the 4168 Finch Ave E East location. Okay, so it's connected to a host name, is a HT Home, and it gives you a description. It's an Intel Wi-Fi 6E card. This is the model number of the card. It's 6E AX211 mod type of model card. Okay? It's an Intel card. It's a manufacturer. So this is the manufactured physical physical MAC address itself. Okay? It's the MAC address. And I told you, it's a unique address. They try not to repeat these again and again. Okay, it's usually it's very unique to the computer. So, and this is called DHCP, and we'll go through all these again. Now, this is my IPv4 address, which is over here. Okay, this is my computer's IP address that is issued to me by my router itself. And this is my subnet mask. This is how it gets divided, and we'll go over it next class. And this is my router's IP address, 192.168.0.1. If you ever want to clear it, just CLS will clear the whole screen for you. It gives you a better screen. Okay. Now, I want to show you guys how. Remember, we talked about ping, ICMP, right? What does ping does? It checks if a device is online through a special testing methodology, or it's a special protocol, which is called ICMP. For us to check device, we can check devices, we can check websites, We can even check certain network connected devices as well. As long as it's network connected device, we can check our websites as well. Let me just show you quickly. Ping google.com. And we can actually see google.com communicate back to us with what it's saying is we're trying to ping google.com. And when you see like this, guys, these are IPv6 addresses, okay? And these are new type of addresses. We'll go through them as well. But IPv4 is what we mostly will talk about in this class. But IPv6 is a newer generation. And I'll explain to you guys next class why we came up with the newer generation IP address instead of using IPv4 address, which is still which is the older methodology. But we can see that it has replied back to us with the reply. We have sent 4 packets. We have sent, it's almost like we sent a 4 high signal, right? We're like, hi. And we received 4 reply back to. So the server itself, Google saying, hey, how are you too? Back to us. We lost 0. So we didn't lose any miscommunications, any communication between. Okay? Everything came back to us. We had a reply all the time. You'll also see the latency and everything as well here. Okay? Average, it took us 20 milliseconds for us to get a reply back, which is very good. But let's say we're checking pings, right? And you can ping this to pretty much everything. You can ping your router as well, which is my router's IP address is 192.168.0.1, which it tells you my router can say hi back as well. It's replying to ICMP request. Okay, it works on ICMP packet level. It's a different level than a different packet. We'll go through these packets just later on in the course as well. But whenever you want to test a connection, or test if something is accessible, or if you want to test something that is reachable or online, you'll do is ping. Now, if we ever want to troubleshoot, if we cannot access certain things, right, we can try to troubleshoot it in a certain way to see where the ping goes, how it travels. All we're seeing is replies. But let's say if we want to know what is the route it's taking to go to google.com, we can actually do something called trace route. So when you go on your Google and type in, I want to, go to Google and type in CTech Training Center, it gives you a direction on how to go there, right? So that the direction, how you travel, we can actually see how it travels, the network is traveling. So it's called trace route. ERACERT, okay, trace route. It's going to trace us a route, how it's trying to access a computer, how it's trying to access a website or the computer, whatever it is, okay? I'm just going to go show you guys google.com again. So you'll start to see okay, 1 second, guys. I just yeah, there you go. I just stopped IPv6. I don't want the IPv6 to be right now. Okay. So I'm just doing it from IPv4 standpoint. So what you guys are exactly seeing is the route it's taking to visit google.com. Okay. So if you see here, the trace route is complete. So right now, this actually tells us how I'm accessing google.com. So when I try to access google.com or when I'm trying to ping it, all it's doing is my computer is reaching out to my router. So remember, this 192.168.0.1, if I type in IP config, see how this is my router's IP address, okay? So it's actually going to my router. My router right now passes on to the ISP. My ISP is TechSavvy. So you can see it's going through several TechSavvy servers and it's reaching other locations. And then it routes and goes through and it goes to google.com. This is google.com's IP address. It's right over here. So it takes 18 hops. These are called hops, 1, 2, 3. These are called hops. But if you see this, google.com takes us milliseconds for us to go through, okay? It doesn't take this long. It happens milliseconds or nanoseconds for us to go through google.com. But you can see the complexity behind how this works, okay? One of the things that we always like for people to do is, if you go on in Google Chrome, what I'm going to do is show you here. If you take and go into what's my IP address, what this will do is this will give you a public IP address. So a public IP address and there's a private IP address. Okay, private as I said, I'll go through but more when we go into the next class. It'll make more sense. I just don't want to overcomplicate things right now. But if some of you guys are on your computer or on your phone is connected to Wi-Fi, let's try to do this. If you want to try to do a trace route to this IP address of mine, but if you want to also share your IP address on the comments, let me try. I'll do it in live and screen for you too, so you'll see how that works as well. It'll be very interesting for you guys to see how this, how we can ping and see, and how does from my connection to your computer, to your network is working. If you guys are comfortable with it, just share your IP address over here. But you guys can, from your computer as well, you guys can try to trace route to this IP address itself. Let's see how this works. Perfect. Okay. So I got someone's IP address. Let me go ahead and put in here, and I'll put my IP address for you guys too. For you guys, so you guys can try and trace route to here. The first thing to see if it's online, let's always do ping. So we always do ping just to make sure the device is online, it's reachable. Okay, so what I'm going to do is I'm going to do ping 142.189.136.14. it seems like you see it's just getting stuck, right? There's no reply. It's saying request timeout, which is telling me that I cannot reach it. Well, we might think, okay, so there could be something wrong. We cannot reach it, right? But let's get more technical into it and see where it actually goes wrong. And this is where traceout becomes a very good tool for you guys to master networking. So let's say if we do this, but this information only provides us with 10% information, right? But whenever we start doing traceout, it gives us a much more bigger picture of where it gets stuck. Does it get stuck leaving our router, or does it get stuck after it leaves our router? So is it in our hands or is it in someone else's hands, right? Is it in the internet service provider's hands, or is it actually getting blocked by Gundeep's firewall if he has a firewall, right? So let's do trace route here, and you'll see the traveling path how it takes. Oh, sorry, guys. We're almost done, guys. All right. All right, let's take a look here. So let's see. We have done the trace route to the IP address that Gandhi has provided. So it seems like when we did the ping, it just said request timed out, right? But let's see here. Like we want to find out has it left our router and has it, where did it get stopped, right? So it seems like let's just diagnose this here. The step hop one, it went to a router, right? So this is 192.168.0.1. This is our default gateway. But number two, it has went somewhere else. Number three, it seems like it's at our Tech Savvy, which is our internet service provider, who is our ISP. It seems like it's going Tech Savvy, it's leading to somewhere else, but it just gets blocked. This is very common, either if there's a firewall or if there's a rule that says, this should not be going through. And this is very common in home networks. That you cannot ping the thing, right? You don't want someone else to come into your computer and trace your computer. And I think several of you guys are studying your cybersecurity, and you know how dangerous that this could be if your IP address can be pinged, right? People can do scanning, people can do certain attacks to do certain amount of damages, right? To test your system. So usually home networks, you don't need to have any incoming connections. They block that. But on a corporate side, you will actually open that up, because you'll have separate services, but you'll have your own firewall. Certain IP address. If someone else has an IP address, you guys want to give the IP address, we can actually do the tracing and see if that works. I know that some IP address does work. Like when we do these classes, some people's, like I think Rogers Ignite does allow to come through. Sometimes for us. Depends. If you guys does anyone else want to share the IP address?
I have on my cell phone VPN, and I tried it, and it was entirely different experience, because it only gave certain 2 or 3 location, and then it's timed out.
Yeah. That's it. Yeah. It depends on your VPN companies too, which you're using. So it's very much fluctuates, right? But but you can see that it's leaving your computer, it's leaving your router, it's going to another exchange, and then it's crashing, right? So, which is a very good sign that it's actually not in your device or not in your router. We actually got someone else's IP address. Now let's throw that, because then you'll see. The thing is, what we're trying to do is we're trying to see where it actually is going wrong, where it's actually stopping, where it's actually getting blocked, right? So let's see. This 99 seems like a Rogers IP address, and usually Rogers IP address we can get through most of the times. Okay, perfect. So if we see here, actually, we were able to land into his home network, which is a Rogers network, right? So if you see here, it's a very good example. And even if you try to ping this one, we should be able to go through by ping as well. Yeah. Which means his router is actually replying back to us, right? So let's go back to the trace route over here. Within 11 hops, we're able to get through it, okay? And always the computer is by default, your CMD in Windows tries to do maximum of 30 hops because it knows if it fails beyond 30, it's most likely unreachable, just to put a limit. But you can actually increase these hops. There's a tweaks you can do to increase these hops, just in case you test them out, right? But here, let's say it's leading from my computer here. This is going to another exchange, same exchange as my Tech Savvy exchange. Is going to my Tech Savvy company's exchange protocol services. It's going to their servers to route against where to go, however they have done the routing, right? Now, if you see, this has landed in the Rogers Toronto Internet Exchange hub. It's here, and this IP address for it, and then it goes to another IP address, and it goes to a Rogers remote management server as well, and then it's going to another IP address, and then it's landing in his in Krishan's home network or office network. Okay. And this is how we can actually see that if this is a successful connection. If it does get stopped, where is it actually getting stopped, right? Which IP address? Is it leaving errors or is it not? The reason why we want to see is this something we can apply changes to, or is not something in our hands, right? Sometimes, like this one, we're trying to ping this IP address, right? If this is not going through and if it's getting blocked over here, there's nothing we can do to unblock this. This is something on the ISP level or the client side, or it's something the vendor side, right? Or whoever the other party is. We can't do anything about it. But let's say after leaving a router, it just stops, or it does not even leave our router. It stops. That's when we can actually troubleshoot and make sure it leaves our router. And this is where the reason why I'm showing you this is going forward, when we do a lot of our labs, you might see a lot of packets just stop. You might not be able to ping. If you were to come in and tell me if it's not ping, the first thing I want to ask is, can you trace out where does it get stopped? So once you get that picture of where it gets stopped, it's easy for us to diagnose and fix the issue. And this is why it's so much important for you guys to understand these commands. Okay. Okay. Any questions so far, guys? Here. All right. Okay, just before we're at the 10:30 mark right now. We have 30 minutes of class more, but I just wanted to cover another portion of this, which is going to be your Cisco packet tracer. I'll open up my Cisco packet tracer. There will be a video that's released to you guys through the LMS portal itself, how to install Cisco packet tracer. But I'm going to show you guys how I want you guys to set up your home network. Okay, I'll just give you guys a brief introduction on it. It is free. It's completely free. Cisco packet tracer. It is for students or whoever wants to learn networking. It's for free. I just have a basic network here, but let me just go ahead and delete this. Okay. But what I want you to do is go ahead and create one of the assignments is going to be simulate how your home network is. Think of all the devices, how many of your laptops you have, right? Think of that and just get a drawing in place. So if you see here on the bottom, you have the devices over here, okay? So you'll see network devices, end devices, which are like your computers, your servers, your cell phones, your VoIP device, anything that receives the end device, okay? What the human being interacts with. The next are components. These components go inside of a machine itself, right? And these are connectors. These are cables which you use to connect them. These are like physical cables. And these are like miscellaneous. They're like maybe like routers, PCs, certain things, miscellaneous things there. And these are like multi-user connection. These are like cloud-based concepts. But these are the the 6 main icons here, okay? Whatever you choose, you'll have a subdivision. If you go to network devices, you'll have routers, you'll have switches, you'll have hubs, you have access wireless device or access points. You'll have security device like firewalls. You also have WAN emulator, wide area networking. And then if you go into end devices, you have the computer, laptop servers, those type of things. And you have like a home, like anything you want to create a home, because you can actually create like a home drawing in this and add devices in, right? To try it out. You have like a small city, and you have like industry, and you have like power grid as well. But what we care really about is the end device. We care about these ones, okay? The end devices. And components we're not going to really touch right now. But connectors, you're going to use something called copper straight through connectors, okay? You're going to use this to connect all the devices together. The crossover, we'll talk about the different types of cabling there is, but mostly you'll be using copper straight through for this assignment itself. Okay. So what I want you to think of is this way. I want you to create your own home network in this simulated. Okay. So let me choose a router here. You can choose pretty much 29001 or 2911. It doesn't matter. But just I'll put one over here. This is my router. Okay. It's my Rogers or Bell router itself that you have, right? Now, your Rogers router itself will have a built-in wireless antenna, but these routers does not. And I'll explain to you guys in the next class, and I'll show you some live demonstration of what this will look like and why it's different. But you'll have an access point as well over here. This is for your wireless, okay? And then let's add a switch in here. This, if you do have devices connected to the cable, Ethernet cable, let's just add a 24-port switch over here. So this is your basic setup, okay? I want you to do this is connect this way, okay? I'll show you how to connect this. I'm going to take a copper straight through cable, connect the routers, gigabyte 00, choose a switch, fast Ethernet 01. And then I'm going to take another copper straight through cable, connect the switch 02, access point 0. This is our basic setup, okay? This is a router, switch, and access point. Now, I'm going to bring in a desktop in here. PC. Let's say at my home, I have one PC that's connected through wired, one laptop that's connected through Wi-Fi. The Wi-Fi one, we're not going to configure right now. There is some programming configuration you have to do. But let's say if I have, and I also have a TV that is connected through online. I think this TV might have it. And as well as my IP phone, my office phone. This is also wired connection, okay? So what I'm going to do is this one is going to stay over here. All the wired connection ones will come down like this. And I want you guys to be creative and add as many devices you guys need to, just to understand that you know how to work this, okay? And I want to choose a copper straight through. I'm now going to connect from my access point. My access point only has one, okay? I'm going to take it from my switch over here. 0 to this phone, to the switch. The phone has to go to the switch. And what I can do is take one more from here, 2 to the PC, and fast Ethernet 0. Oh, can you guys actually it's you guys did see that, right? Like when we choose here, fast Ethernet 0. Oh, this does not have TV, does not have it. That's wireless as well. But when I let me just remove this. So when I put them here and I connect them to the PC, you see fast Ethernet 0. A copper straight through is just like the Ethernet cable I showed you, okay? But for the next assignment, I want you to go ahead and I'll send you guys a video on how to set this up and install on your computer. But I want you guys to create a home network with multiple computers, multiple laptops, multiple TV, just so you know we have all the devices, most of the devices at home in this mapped out, okay, for you guys. You'll have one router. You'll need to put in one router, one switch, one access point. And the best thing about the packet tracer is we can actually emulate a router itself, right? And we can actually go in and program a router. We can actually program a router, and I'll show you guys how to program a router. We can actually write most of our script. 90% of the script works in here, 90% of the command line works in here. The 10% is more of a physical device needed command, so we won't be able to work with it here. But at least 90% of the commands we can work with here, okay, for the exams. But for the CCNA exam itself, the Cisco packet tracer, it's more than enough. That's what Cisco recommends as well, okay? All right, guys. So you guys will have the recorded video for how to sign up for Cisco Packet Tracer. And you guys will have a small briefing about the IP address and the subnetting as well that you guys can watch. And this recording video should be downloaded and uploaded within 24 hours, okay? This classes. But that's all I have for this class today. Anyone, any questions before we let go? About the assignments Or do you guys know what assignments you guys have to work on? If there's any question, please ask. Go ahead.
Yeah, sorry, I'm new to that. So where do I is that like a app that you got download, or is it like an online login?
No, it's an app, but I'll send you a video in the LMS itself, and there's a video on it. It's a 4 minutes video. It's very easy. Go in and there's a sign up process which I videoed it. It should be in the LMS, and I'll send it to you guys in the email as well.
Okay, thank you.
Once the video is uploaded, once this class video is uploaded, I'll send you an email with all the things we cover and for the next class, and as well as for the next class, and as well as all the links you guys will need. Okay.
Okay, thank you.
Yeah, no problem. Yes, Manjeet, go ahead.
I just want to let you know I have already installed this. This is
Perfect. Very good. Very good. Yes, very good. Go ahead, Imran.
I have a little bit different question. As you told me that we know switch is for local area network, and it usually go by the Ethernet cable connection. So when we're talking about the Wi-Fi connections and Wi-Fi network, which in a modern network everywhere we are using. So is there any device which work exactly as a switch, but we can call it a Wi-Fi switch, so that all the nodes connected with the Wi-Fi can communicate in between, just like when they're connected with the switch, and they can communicate. Communications means like a file transfer or the message communication.
Within the packet tracer. So if you're asking, or are you asking in real life?
In a real life.
Oh, okay. So you're talking about a like a Wi-Fi enabled switch, right? You're talking about something like that, right? In that fashion. Correct me if I'm wrong.
Yes, just
Okay.
like we have a switch. What would be the Wi-Fi version of it?
Yeah. So right now, your modern, your routers that you get from Rogers or Bell, whatever it is, right? It has what we call a 3-component built in one, 3-in-1. So it has a modem, it has a router, and it has an access point. It has a switch and access point as well. So it has actually 4-in-1, to be honest. That is a Wi-Fi enabled switch, right? A switch that enables you to do all that. But in a corporate environment, you don't use that. It's because if one device fails, pretty much have all 4-in-1 fails, right? So you'll have it separated out, just for ease of management and redundancy in failure, right? It's just for failure purpose. But your modern router you get from Rogers or Bell, it actually has a modem. We'll talk about all these too. Modem, it has a router, it has actually a switch, and it has an access point as well, built in all in one device.
Yes, you can convert it to either as a switch or access point, or just as a modem, or you can make all 4. But in a corporate environment where only and only specific for Wi-Fi, how do they set up? Is there just a router kind of thing, or they get a bigger router?
Okay. I'll show you. Give me 1 second. Just give me 1 second. Let me see if I have that here. Okay, I don't think I have it physically here, but I'll show you. So you will actually have something called, have you ever seen a corporate access point, like a Aruba access point?
No, I did not.
Okay, no problem. I'll show you. I actually have several physical devices, but I think I took it to another facility to show them demo. So here, I'll share the screen. So right now, what is really famous in the market right now is called Aruba. Cisco has the same thing too. It's just Aruba Access Point AP. So they really look like this. They're just a device that goes on top of the ceiling. All it does is it gets mounted onto the ceiling. You run an Ethernet cable to this. Yeah, see here, it goes like this. you'd actually, in here, there's actually a portion where you can plug in an Ethernet cable. See if I can zoom in. So in here, one of these, you put in a Ethernet cable. You actually run a cable to these. You can actually scatter them across the whole office. So if you have like a 20,000, 30,000 square feet office, you can assign one every 10 feet or every 20 feet or something like that, where you have a very good Wi-Fi coverage, right? But they just act like a shell. They just beam out Wi-Fi signal, and you can connect to them. I wish I had one yesterday at my office, but I took it home. But yeah, these are devices that does Wi-Fi, singly just Wi-Fi. And from the switch, just like how I showed you how you would connect this to a switch itself. And the switch, we call it power over internet switches.
This is what I do on a daily basis for stuff.
Hey, Gandeep, so go ahead.
Yeah, so the, basically from the router, we feed it to the 24-port switch or 24 switches, and then we take across the building.
To whatever you want. Yeah.
Yeah, right. So we feed the Wi-Fi with this and stuff. So this is
Gandeep, your voice is it's too much repeating, man. You have I think you might have to switch it to a mic, or you might have to switch it to a headset. There's a lot of echo there.
Is it better now?
Yeah, slightly better. Yes, go ahead.
Okay, perfect. Yeah, I was saying we do. This is what I do on a daily basis. Every other day kind of thing. So if it's a big apartment building or a big office, we feed the Wi-Fi board with multiple access points and feed it that to the switch that'll and then feed that to the router. Well, the other way around, but it's,
yeah, exactly. Yeah, just so what you said is on his day-to-day routine. What he does is he feeds the cable from the router to a 24-port switch, which I'll show you guys how the 24-port switch looks like. So this is actually a 24-port switch. If you guys can see, it's a pretty long one, right? So these are all the Ethernet ports. So it'll actually take a connection in from the router and goes into any one of these ports over here. And then you have 23 ports you can use for any sort of connection: computers, access point, pretty much anything that connects to the Ethernet port, right? And your access points connect there too. And you can run multiple access points. And the best thing is, this itself will deliver the power to the access point. So you don't need to have another power cable. It's called power over Ethernet. Okay. Go ahead. Jinisha, you had any question?
No, sir, sorry.
That's okay. No problem. All right, guys. Any other questions?
Hi, what Imran asked was all about the layer 3, like the switch acts as a router.
Can you repeat your question here, Manjan?
I want to ask you about what Imran asked before. Was he asking exactly about our switch acting as a router, about the layer 3? I did not understand his question. Can you explain it?
I think it's Imran was asking, okay, so what is the equivalent to a so we are a switch, right? So what happens if it's a Wi-Fi device? How does that work? How does it get connected? It's more like, the questions of how does it interact? So we have switch directly connects to a computer, right? But what happens to access point? How does that work?
Okay, thank you.
No problem. I just want to get to this.
So I have another question about a switch.
Go ahead.
Managed switch and unmanaged switch. So in a real working environment, in a corporate environment, what is the usage of both of them, like managed and unmanaged? Like where they give them benefit?
Yeah, for sure, man. That's a good question. So unmanaged switch, which means you cannot make any changes, you cannot apply any sort of commands. You cannot do any sort of modifications to it. You can only use it as is. You cannot do anything. It's just like, switches you go on and got from a Canada computers for like 20, 30 bucks, right? There's no usage behind it. So these ones, which I just showed you here, this is what we call a managed switch. This is what we call as a managed switch. So these things, we can actually segregate it. We can apply some rules to it. We can say, these ports are, they're separate and they're not on the same network. We can put some isolations. We can say anything that's connected to these ports are considered as these groupings. So we can do a lot of manipulations to the switches for corporate environment. And for corporate environment, it's always better to go with a managed switch than unmanaged switches. So we can apply rules and we can apply formatting. We can do pretty much whatever. Go ahead, Kabir.
Yeah, so so with the managed switch, you could set static IPs and you can assign puts that it assigns some rules to, so it helps with IP conflicts or it helps with stability of the network, because once you daisy chain a bunch of switches, you need something that we know what's going on with the switch, right? So unmanaged is just plug and play. Managed is you actually go into the stuff that is.
Yeah, it's exactly. It's managed switches are much more better for you can manage them. You can apply rules. You can apply set permissions. You can do manipulations, right? But anything that's not managed, you're just getting it and you're just playing it. It's more better for home uses or basic uses, but it's not really friendly for corporate environment. Any other questions, guys? All right. As I said, please, for your assignment for next week, whenever you guys come, before you guys come in, finish the packet tracer, and you guys can send me the packet tracer as well. And can you guys try to do a trace route for 5 different websites and just see how that works and put them in a document? You can email them to you. I just want to see how the trace route works for you guys and if you're able to successfully. You don't have to. This is just more of activity for you guys. But it's just take a screenshot and see if that how it is and just send it to email. I just want to see what you guys are able to 5 different websites to see how the traveling works. And if you guys have any questions, we can go through it too. Memorize OSI layer 1 to 4. And memorize port number, which I'll be adding that into your LMS portal. Okay, tomorrow by end of day tomorrow you'll have that. But for next week, we'll be covering subnetting, VLANs, routing basics, and Cisco CLI practices. Okay, basic practices. All right, team. If you guys have any questions, please ask me. But I'll have this class recorded. It takes me around 6 hours to get the recording from Google itself. Sometimes it depends. But within 24 hours, we'll have the recorded and we'll upload it to LMS. As soon as I upload it, I'll send you guys an email stating that this has been uploaded. And I'll give you guys introduction to anything else that I want you guys to cover. And then just a briefing about what we'll cover for the next week and what you need to come prepared for next week. Okay? Go ahead. Go ahead, Gabriel.
Yeah, thank you. Regarding this assignment, draw your home network diagram, Cisco packet tracer. Are you saying how to install the Cisco packet tracer is on the LMS?
It will be on the LMS in about it'll unlock you guys tomorrow. It is already in the LMS, but it'll get unlocked tomorrow.
Oh, okay.
Yeah.
Oh, okay.
Because I don't want to. I want to unlock it while I upload the recorded video too. Sometimes it crashes our LMS. That's the reason why.
Okay, because there was a time I installed the Cisco packet tracer, and I think it's telling me password and I was unable to make use of it. I went.
Yeah, don't worry.
Okay.
Yeah, the video is clearly explained how to sign up for a packet tracer. It's very easy. Yeah.
Okay, thank you.
If you ever had it before, just sign up using a new email. It's not complicated. This video, okay. It's 3 or 4 minutes video. I think it's very easy.
Okay, thank you.
Worry. Okay. No problem. Thank you. All right, team. Thank you so much all for joining at 9 a.m. on a Sunday. I really appreciate it. I know you guys are all working and busy, but I don't want to take too much of you guys' time. But I think that's all for today. And I will get the class recorded. And as I said, once I upload it, so as soon as I have it, I'll upload it and I'll send you guys an email with all the introduction for next week as well. But I'll see you guys tomorrow at 9 a.m. sharp. Okay. Thank you guys. Have a nice day. Bye-bye.
Thank you.
Thank you.